Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m+1 or 9m+8. So since we can find that the common number we can find in these three terms is 9, so let us take one of our positive integers b equal to 9 and a be any positive integer. According to Euclid's division lemma, we know that a equal to bq plus r, where 0 less than or equal to r less than b is the condition. So applying b equal to 9 in this equation, we would get a equal to 9q plus r, where 0 less than or equal to r less than 9. So now we have 9 values of r, and for which we have to solve the equation. So for r equal to 0, we have a equal to 9q. Now in the equation they have asked us to show that the cube of any positive integers of the form 9m, 9m+1 or 9m+8. So our integer is a here, so we have to cube the positive integer now. So cubing on both the sides, we would get a cube equal to 9q whole cube. So that would give us a cube equal to 729 q cube. If I take out 9 as common, I would get 9 into 81 q cube. And instead of this term, I'll replace with the letter m. A cube equal to 9m, where m equal to 81 q cube. Now for r equal to 1, we have a equal to 9q plus 1, cubing on both the sides. We have a cube equal to 9q plus 1 whole cube. Applying a plus b whole cube expansion here, we would get 9q whole cube plus 1 cube plus 3 into 9q whole square into 1. So I am just omitting the 1 because into 1 is anyways 3 into 9q square, plus 3 into 1 square into 9q. So instead I'll just omit the 1 here. A cube equal to 729 q cube plus 1 plus 243 q square plus 81 q. A cube equal to, if I take out 9 common from these three terms, I would get 9 into 81 q cube plus 27 q square plus 9q plus 1. Instead of this term in the brackets, I will replace with the letter m. A cube equal to 9m plus 1, where m equal to 81 q cube plus 27 q square plus 9q. Now for r equal to 2, I'll have the equation a equal to 9q plus 2, cubing on both sides. I will have a cube equal to 9q plus 2 whole cube. So if I expand this, I would have 729 q cube plus 486 q square plus 324 q plus 8. So if I take these three terms and take out 9 as common, because I can't take out 9 common from this term, 8, so I would be left with 9 into 81 q cube plus 54 q square plus 36 q plus 8. And this entire term in the brackets I will replace with the letter m. It would be a cube equal to 9m plus 8, where m equal to 81 q cube, 54 q square plus 36 q. My students generally stop with these three because they just find 9m, 9m plus 1 and 9m plus 8, but the question actually goes even further because we have to solve it for all the 9 values where r lies. So from 0 till r equal to 8. If you want to fast forward, you can fast forward to 2x speed on YouTube. You have that option, or you can just keep following me. R equal to 3, a equal to 9q plus 3, cubing on both the sides, a cube equal to 9q plus 3 whole cube, a cube equal to 729 q cube plus 243 q square plus 243 q plus 27. So now in all of these 4 terms I can take out 9 as common. So if I take 9 as common, I would get 81 q cube plus 27 q square plus 27 q plus 3. A cube equal to, instead of this term I will replace it with m, equal to 9m, where m here is equal to 81 q cube plus 27 q square plus 27 q plus 3. For r equal to 4, a equal to 9q plus 4, cubing again, cubing on both the sides, a cube equal to 9q plus 4 whole cube, a cube equal to 729 q cube plus 243 q square 9 7. So here 4 cube is 64. We get in a plus b whole cube expansion, we get 4 cube as 64. So instead of writing 64, I have written it as 63 plus 1 so that I can take out 9 as common, and I can rewrite my equation as 9m plus 1. A cube equal to 9 into 81 q cube plus 108 q square plus 48 q plus 7 plus 1. A cube equal to 9m plus 1, where m equal to 81 q cube plus 108 q square plus 48 q plus 7. For r equal to 5, a equal to 9q plus 5, cubing on both the sides. A cube equal to 9q plus 5 whole cube. A cube equal to 729 q cube plus 405 q square plus 135 q plus 125. And if I take out 125, I will split it as 8 plus 117. Sorry, 100. Yeah, 117. Now I can take out 9 as common and leave the 8. So that would give me a cube equal to 9m plus 8, where m equal to 4, r equal to 6, a equal to 9q plus 6, cubing on both the sides. A cube equal to 9q plus 6 whole cube. A cube equal to 729 cube plus 216 plus 1458 q square plus 972 q. If I take out 9 as common, I can take out 9 as common from all the terms, so that would give me a cube equal to 9 into 81 q cube plus 24 plus 162 q square plus 108 q. A cube equal to 9m, where m equal to 81 q cube plus 24 plus 162 q square plus 108 q. For r equal to 7, a equal to 9q plus 7, cubing on both the sides. I would get a cube equal to 9q plus 7 whole cube. A cube equal to 729 q cube plus 343 plus 1701 q square plus 1323 q. A cube, so instead of 343, I will write it as 342 plus 1. A cube equal to 9 into 81 q cube plus 189 q square plus 147 q plus 38 plus 1. I mean, instead of 342, if I write 343, I'll write 342 and plus 3 plus 1. From 342, I can take out 9 as common, and then I'll be left with 38. And the plus 1 will be left outside the equation as written. So we can write this equation now as 9m plus 1, where m equal to 81q cube plus 189q square plus 147q plus 38. For r equal to 8, a equal to 9q plus 8. Cubing on both the sides, I would get a cube equal to 9q plus 8 whole cube. A cube equal to 729 q cube plus 512 plus 1944 q square plus 1728 cube. A cube equal to, if I take out 9 as common, and if I let me split this terms into 504 plus 8 so that I can take out 9 as common. Now from all these terms I will take out 9 as common. So now I'll get the equation 9m a cube equal to 9m plus 8, where m equal to 81 q cube plus 116 q square plus 192 q plus 56. Now, after doing the entire problem, you must have understood that the cube of any positive integer is either of the form 9m, 9m plus 1 or 9m plus 8. So we can finally conclude that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8.
Download the solution link from the description box below.